Assalamualaikum dan selamat pagi buat semua yang hadir ke sesi webinar unit pasca siswa Zah UiTM cawangan Perlis. So untuk makluman, hari ini unit pasca siswa Zah menganjurkan 3 seminar serentak. I'm the expert at UiTM Perlis branch, dan kita ada 3 seminar 1, 2 dan 3 yang bertujuan untuk mempromosikan potential postgrad supervision for prospective students. So untuk tidak melengahkan masa, saya memperkenalkan speakers kita pada pagi ini, iaitu Encik Mohammad Hafiz bin Ismail dari Fakulti Sains Komputer dan Matematik. Yang kedua adalah SR Dr. Masayu binti Haji Norman dari Fakulti Seni Bina, Perancangan dan Ukur. Dan ketiga adalah saya sendiri, Wan Shazelin binti Wan Shahidan, juga daripada Fakulti Sains Komputer dan Matematik. So saya akan mulakan dahulu sharing saya, just short sharing sahaja. Okay, pada yang Kak Doktor boleh nampak tak saya punya ni? Boleh nampak tak saya punya slide?
Boleh.
Thank you. Kepada yang our potential prospective students, kepada yang belum mengenali saya Wan Shazelin binti Wan Shahidan daripada Fakulti Sains Komputer dan Matematik, Jabatan Statistik dan Matematik. So saya punya master dalam bidang Quantity Science daripada UiTM Shah dan juga bachelor dalam bidang Decision Science daripada UiTM lah. So saya punya research interest saya lebih kepada operation research dan juga optimization, di mana dalam operation research ni is more to a problem solving approach that apply scientific methods and techniques, which is selalunya dia basic kepada development model, right, testing the model, implementing the model and also using the model lah. So that is more to operation research. Dan for optimization method pula selalunya based kepada, we are focus kepada minimizing dan juga maximizing objective function subject to constraint that yang kita set dalam kita punya model. So kalau ada pelajar yang mungkin punya soalan ataupun berminat untuk sebarang pertanyaan berkenaan dengan operation research ataupun transition, boleh kontak saya di nombor yang tertera. Okay, so itu saja daripada saya, just short sharing saja. So saya akan teruskan dengan speakers yang kedua. Encik Mohammad Hafiz bin Ismail dari Fakulti Sains Komputer dan Matematik. So dipersilakan Encik Hafiz.
Okay, sorry, ada technical difficulties sikit tadi. Okay, sekarang dah okay dah. Okay. So, kejap lagi saya akan bagi display slide. The slide difficulty sikit. Okay, present. Okay, hello?
Ya, okey.
Okay. Okay, Assalamualaikum. Okay, nama saya Mohammad Ismail. So this is the introduction. So okay, I have a Bachelor of Computer Science from UiTM, UC Technology Malaysia, and Master in Information Technology from So I'm a member of Pattern Analysis and Machine Learning R&D group. So terima yang diberikan pada saya patut bagi talk lah berkenaan dengan research interest. Bukan saja berkenaan dengan saya tapi dalam RIG lah, RIG group ni iaitu Pattern Analysis dan Machine Learning. So ada seorang lagi ahli dalam RIG ni iaitu Dr. Tajur Rosli. So Dr. Tajur ni merupakan salah seorang ahli jugalah dalam RIG ni. So key point dia mungkin saya nak kenalkan sikit berkenaan dengan deep learning, deep neural network, edge computing device, sedikit introduction, image classification versus object identification and some of the personal project. So kebanyakan yang potential student mungkin ada pernah dengar berkenaan dengan deep learning. So deep learning now is a buzzword. So it is an umbrella term for deep belief network, convolutional neural network, recurrent neural network, and etc. And there are many application of deep learning field. Sekarang ni dia banyak dipakai dalam macam-macam bidang lah, engineering, agriculture, GIS, so civil engineering nak detect cracks ataupun concrete identification of virus dalam bioengineering, biotechnology. So mostly yang dalam RIG ni kita concentrate dalam computer vision and machine vision. Tapi dia ada banyak lagi lah, dia ada banyak speech, audio, okay, NLP, natural language processing, audio recognition, forecasting, regression and clustering. So but our RIG concentrate more on computer vision and machine vision. So now I'm trying to focus more on deep neural network. So deep neural network was introduced in 1980s and it needs a lot of processing power. So that's why it doesn't took off in 1980. So dia tak popular lah. But now it because of the advancement of computer technology, computer are getting faster and we are getting more advanced GPU. So deep neural network are becoming much more feasible. So here are the comparison between artificial neural network and deep neural network. So this is very simple, okay, simple structure. So biasa artificial neural network or ANN usually dia akan ada neuron input output layer. Selalunya this is mathematic model. Tapi sebab kita pun ada audience dari pelbagai bidang, so ni saya ringkaskan lah. So between artificial neural network and deep neural network dia punya neuron dia banyak. So artificial neural network biasa neuron dia ada macam 2, 4, 8, 32. But in deep neural network starting neuron dia biasa bila saya bina deep neural network dia minimum pun biasa-biasa ada 64. Okay, 64 sampai 2000 lebih dia punya neuron dia. So it can have 124 neuron per layer. So deep neural network is also a broad term for convolutional neural network and recurrent neural network. Okay, this is part of our focus lah, focus for our RIG. So jadi kita akan tengok our works. Okay, next our RIG also specialize on edge computing devices. Deep neural network, okay, dia luas, tapi kita focus more on edge computing devices. So this is a sample of edge computing devices. So we have Intel Neural Compute Stick, and NVIDIA Jetson Nano. And then this one kalau ada yang familiar, kita panggil benda ni Raspberry Pi, ESP32 camera, and it also can work on your average CCTV. So CCTV, this is also the size of the board. So edge computing device memang kecil. So why edge computing device? Sebab sekarang ni trending emerging technology sekarang ni dia depend on edge computing device. Ataupun dengan nama lain adalah IoT. Okay, ada setengah dia panggil ni IoT. But in terms of sekarang ni kita lebih pada IoT, dia panggil edge computing devices. Ini maksudlah handphone lah, mobile phone. So according to Cisco, so edge computing device should provide local processing support, data collection, offline support, and also machine learning. So we are concentrating more on machine learning, data collection in order to solve problem. So macam agricultural problem or GIS problem, thing like that. So why we concentrate more on edge computing? Because there are, senang cerita dia macam masih lagi blue ocean lah. Okay, red ocean versus blue ocean. It's still new. Okay, there's a lot of room to explore. So that's why we concentrate more on edge computing. So the advantage that it have less dependency on the cloud, so dia tak pakai internet sangat walaupun dia IoT. Okay, it can create intelligent system, so dia boleh integrate dengan smart city ataupun smart home. So sekarang grant pun banyak concentrate on smart home, smart agriculture. So this is where edge computing come from. So this is a sample of edge computing. So kita capture image, kemudian kita process in the device. So device tu memang kecil, kurang kita tengok tapak tangan kita, sebenarnya device tu paling besar, besar tapak tangan, dan dia kecil lagi pada tapak tangan pun ada. So ada tapak tangan lah between that size. So DC comparison versus cloud computing. Kalau cloud computing dia depend more on the internet. They depend more on the internet. Right. Next. Okay. Next. On image classification. Sebab kita cakap tadi berkenaan dengan deep neural network. So this is what we do. We do image classification and object detection. So dia ada beza. So ada setengah orang kata sama, tapi sebenarnya dia berbeza. So image classification dia kenal seperti satu objek. Macam objek, kalau tunjuk gambar kucing dia kata cat, but in object detection dia boleh bezakan dalam satu gambar between cat, dog and duck. However, object detection can also be used to identify multiple classes at the same time. Macam building, people, dia boleh kira bentuk bilangan objek. So this is for counting object and differentiating object, and another one is to differentiating between two object within the same class. So dia ada perbezaan lah apa yang kita work out sekarang ni. So dua-dua kita buat. So for object detection, dia sebenarnya kita kena fikir terms macam ni lah. Object detection, kita untuk bezakan between apple and oranges. Dua benda berbeza, kita nak minta komputer tu bezakan antara dua benda, apple and oranges. Cat and dog, duck versus elephant. So dua benda berbeza. But in image classification, our work are more on identifying subtle differences within the same class. So contoh kita ada dua gambar kucing. Okay, kalau dua gambar kucing ni object detection tak dapat nak beza sebenarnya sebab dia kata dua-dua kucing. But image classification dia boleh bezakan. Okay, ini kucing Persian. Okay, ini kucing British short hair. So dia dapat beza between Persian, British short hair cat. Ahmad versus Abu instead of human versus building. So this is object detection. But there are times where we need to rely more on object detection, and there are also times where we need to rely more on image classification. But so far our work are much more concentrated on image classification. Dia ada satu je project yang setakat ni kita buat rely on object detection lah. So these some of the project that we've done. So gate detection, we can detect the gate open versus close. So this one we've done training to detect closed and open gate. So we use mobile net architecture trained on Intel Core i5 6th generation computer with EVX. So this one is very simple structure. So this one behind the scene, we train it on a computer, on a workstation, and then we run it on a Raspberry Pi embedded computing device. And then we link it with camera, CCTV, TP-Link CCTV. So this is one of the result. So, right, kita dapat dia punya status. Kalau gate open, dia kata open. Gate close, dia akan kata close. Kemudian dia bila open terlalu lama, dia akan send notification lah. Kita boleh buat untuk send pada Telegram. So this is the very definition of edge computing yang vision kita akan integrate dalam smart cities lah. Smart cities macam garbage collection ataupun dia nak detect bus, nak arrive ke tak, smart agriculture and so on. So this one also the same. Cuma ini grass status. So grass status sebab kita nak monitor grass height. So bila grass terlalu tinggi, maka dia akan send notification untuk potong rumput. So, okay, this is just the first stage. Nanti mungkin kita punya services integration akan lebih tightly integrated. So, mungkin ada kemungkinan nanti dia boleh send juga API terus pada servis untuk potong rumput macam servis Zero ataupun Grab, yang jenis macam Grab, dia akan hantar terus, kemudian orang terus datang without human intervention. Yang tukang potong rumput terus datang without kita bagi arahan. So this is one of the work. So kita akan train, lepas tu dia akan bagi jawapan lah. Dia akan bagi jawapan sama ada rumput panjang atau pendek. Kalau rumput panjang dia akan send notification lah. Every 2 weeks also. So this is also our work, preliminary work lah for agriculture and then for lawn keeping automated. So sebab dia memang tak ada sensor punya nak detect rumput panjang ke tak, memang tak ada sensor. So we've done this through the use of edge computing through convolutional neural network and deep learning. Okay, next we are going to look into traffic condition auto detection. So this one we've already published. Okay, this one we have already published this work. So one of the problem statement of highway traffic auto detection is that highway traffic condition have only been the subject of national news, especially during the festive season. Sebab bila festive season macam raya ke ataupun tahun baru, merdeka, cuti bersambung kan, cuti berkembar, highway selalunya akan penuh. So Lembaga Lebuh Raya Malaysia akan telah letakkan beberapa traffic camera di sepanjang lebuh raya untuk monitor traffic. Tapi bila kita tengok TV selalunya, dia akan ada operator kena monitor the camera untuk tentukan sama ada highway tersebut padat ataupun tak, ataupun busy ataupun tak, okay, jam ataupun tak. So you still need a human to look walaupun dia ada kamera. So wouldn't it best if this thing can be automated? Okay, kita ada kamera, we have an intelligent system. The intelligent system can analyze the graphic, okay, the images in real time, and then it can send a report, okay, traffic report, or update it on the map, okay, update it on the map. So dia akan nampak pinpoints ataupun heat map. So dia akan nampak bahagian mana yang akan ada traffic jams. So this is what we have done previously. So the weaknesses of highway traffic detection. So weakness is still the current system still need human. So Lembaga Lebuh Raya Malaysia masih perlukan manusia, need human. So human tu dia akan tengok lah kamera satu-satu. Kalau kita pernah tengok TV kan, TV masa musim raya, dia akan ada seorang wartawan tu, dia akan tengok dekat kamera, lepas tu dia pergi belasan kan, trafik. Okay, ada kita aliran trafik padat menuju ke arah Lebuh Raya Rawang ke apa ke kan, dia semua kata macam tu. So it still need a human. So the strength is that we have now the technology that can perform automatic traffic condition classification, which the computer can work 24 hours a day, okay, 7 days a week. And then this can be done automatically and kita boleh update dalam situation room. Kalau kita ada macam situation boardroom, dalam tu ada map, okay, dia kan boleh update secara automatic without or with minimal human intervention. Sebab kalau LLM dia nak monitor pun dia punya staff dia tak akan ada 24 jam di depan kamera. So, okay, and then our opportunities that during this work, we found out that lembaga lebuh raya make the camera footage available to the public for free. Dia memang letak je untuk semua orang tengok. So cuma kadang-kadang tu dia kan ada downtime lah, outage. So what we've done that we've started to collect these LLM traffic camera atau lembaga lebuh raya traffic camera since 2016. Tapi untuk jimatkan ruang ataupun kita nak kurangkan beban, kita ambil footage ni 15 minit sekali. Okay, kita sample. So in 1 hour we have 15 minutes. So we have 4 image in 1 hour. So kan 15 minit, so 60 image within one day, and then one day have 24 hour, kita ada 900 image. So and then more, 1 year kita ada 300,000 image. Sekarang ni dah 3 tahun lebih, kita ada hampir 1 juta lah image sekarang ni dah kumpul. So ini adalah antara image highway traffic auto detection work that we have done. So kalau sebagai manusia, kita boleh tengok lah, kita boleh tengok benda ni, kata yang mana satu busy, yang mana satu tak busy. Dia kata ni busy atau tak, ataupun busy atau tak dan sebagainya lah. So as a human, we can identify it easily. But the thing is that kalau human kita mungkin letih lah, lama-lama dia akan jadi orang putih panggil tedious work. Okay, tedious work. So we've run it and train it these images sebanyak 300,000 lebih ke 900,000, kita train dia dalam neural network. So this is the result, kita run dia boleh bagi satu certainty factor, kata benda ni not busy with certainty of about 77%. So this one is busy, 83% dia boleh beritahu. So okay, this one has already been published dalam special series on automatic detection of vehicle movement on interstate highway through traffic camera monitoring, okay, during coronavirus pandemic, right? Okay, so ini dah publish. So this is one of the work yang accepted lah. So yang ni sample lah, sample image yang di collect. Memang ada beratus ribu. Sampai komputer pun jam lah kalau nak load. Sebab kalau saya nak train ni, saya kena buka, tak boleh buka Windows, saya kena buka Linux. Sebab kalau buka Windows, dia tak boleh nak load sebab terlalu banyak sangat. Dia jadi so okay, this is the next work. Okay, this one is pending publication. So Indian mackerel fish effect detection. So Indian mackerel ni nama glamour lah, nama yang biasa kita kenal ni ikan kembung sebenarnya. So the Indian mackerel fish detection ini, kita problem statement ni is we want to differentiate between fresh and non-fresh fish, and we want to detect if the fish have defect on its body, suitable for quality checking and triage of the quality. And then we want it to be used in conveyor belt for fish sorting. Ini kan dia boleh guna dalam field of fisheries ataupun agriculture. So ni ada sample image yang kami collect. So ada yang damage. So ini damage yang dah tak fresh, and this one is a bit fresh. So ini sampel-sampel dia, banyak sampel. And then we also have a video that can identify, like can identify the fish. So yeah. So that's one of our work. So dia tak ada video, tapi tak ada kali ni. Okay, ini video lain. So next, okay, this is also another one, Malikix. So ini boleh download juga daripada internet. So we can still download this from the internet. So basically, this is an application for identifying kuih tradisional Melayu lah ataupun Malay cakes. So you can download this if you have Android, okay, Android application. Okay, if you have Android phone, you can download this. Okay, dia akan kenal macam ni lah. Dia kata bahulu kalau ada. Okay, dia akan kata benda ni bahulu and you can recognize it anywhere. So, alright, for this, the application that we have developed can identify 35 type of Malay traditional cakes or kuih. It is trained on Mobile Night V2. We plan to migrate it to EfficientNet for more accuracy. And then we took it about 1 year together, the data set and training the data. Alright, okay, this yang saya tak dapat nak display tadi lah, ikan kembung. So yang ni, okay, yang ni kalau boleh nampak, dia boleh identify damage, okay, damage on the fish. Okay, you can identify whether the fish is damaged or not. Okay, dia boleh identify kata fish ni dah rosak. Okay, damage. Okay, the type of fish and the name of the fish. Okay, whether it's fresh or non-fresh. Tapi this is still work in progress. Okay, not fresh and something. So we still need to tuning, but the work is pending publication. So I think that's all on our presentation. So for the info nanti boleh tanya Q&A. So boleh buka kot rasanya Q&A. Nak tanya apa-apa?
Okay, terima kasih Encik Muhammad Hafiz. Kita dulu QA tu di akhir session kan.
Okay.
Hafiz boleh ya?
Okay, tak apa, no problem.
Okay.
Okay, baik.
Jadi sekarang ni kita tanpa mengambil masa kita menjemput SR Dr. Masayu binti Haji Noman daripada Fakulti Seni Bina Perancangan dan Ukur untuk sesi perkongsian beliau. Jemput Doktor.
Okay, thank you very much Wan Nur Shazelin and also Encik Mohammad Hafiz Ismail for the interesting presentation just now. Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning to everyone. So first and foremost, I would like to say thank you and congratulate to you all for successfully spending time to join this valuable sharing session and take the opportunity to gain the experience from all the speakers. Okay. As an introduction, my name is Dr. Masayu binti Haji Noman. I'm from Faculty of Architecture, Planning and Surveying from UiTM Perlis. And I have been focused in my research area for almost 12 years. Okay. All right. Without further ado, I would like to share my slide. All right. So everyone can see my slide.
Nampak Doktor, nampak.
Right, thank you. Okay. Okay. Right. So for information, my specialization actually in two areas, which is remote sensing and also geographical information science, which is GIS, because as we know that these two areas cannot be separated actually. Okay, because they are playing an important role in providing the geospatial informations. And usually we integrate these two methods in order to have a better decision. But However, my interest is more on remote sensing area, which I'm working with multispectral and hyperspectral satellite image. Okay, so by utilizing these two types of image, we are able to obtain such a detailed information of research that we are working on. And actually there are many applications, okay, that has been used this image. For example, we can classify the roof materials, we can identify the roof degradation status, okay, and then we can discriminate land surface features and landscape patterns. We also can identify and characterize the materials for any materials, for geology especially. And we also can map, okay, in detail the tree species within the forest. Okay. Right. So in this remote sensing area, I'm focused on image processing, okay, whereby whether I optimize the existing method or techniques, or I develop or I propose a new method in order to get a better result. Okay, so the question here is why I have focused on image processing, because this is because I noticed that how important it is in determining the high of accuracy results. Okay, so I would like to emphasize here that if we are not concerning on this issue, I mean in this image processing stage, it will give a big impact to our analysis, okay, and so on to the decision that we make. All right, so for that purpose, I have used object-based image analysis, which also known as OBIA technique. Okay, and I also apply a deep learning for analyzing and interpreting large amount of data. It is quite similar with Encik Hafiz just now, because by using deep learning, it can make our process more faster and easier. Okay, so rather than that, I also apply programming base, for example, Python to process the satellite image. Okay, so all this kind of advanced method will help us a lot. Okay, and the result from this optimization, from this result, we can optimize the workflow, okay, and we can solve the issue of misclassification. This is very, very important issue in remote sensing. Okay, and then we can avoid losing time, and we can ensure the accuracy and quality of the result. Okay, for my study, for example, I apply this proposed method in order to monitor, to assess, and to evaluate the urban environmental, okay, especially in rainwater quality. Okay. So what I have done to solve the rainwater quality issue is I have classified the roof materials and their degradation status. Degradation status means whether the roof is new or old, because it has been proven by previous study that the old roof materials will contribute to bad rainwater quality. Okay. Okay, so this is the example of rainwater harvesting system that are available in Malaysia. Right. So in my study, I have integrated two data, which is I use high resolution image WorldView 3 with 0.3 meters spatial resolution, and also light detection and ranging data, which is LiDAR. Okay, and also the techniques that has been applied, as I said, is OBIA. Okay, so actually there are a number of optimization techniques has been applied. For instance, fusion method and several classifier algorithms, and as a result, okay, I managed to produce this kind of classification whereby I classified the roof, okay, the roof materials actually, not only the roof, because I'm using the high resolution image. So rather than classify the land use, land cover, for example, building, vegetation, road, and etc. So by using this, I managed to classify in detail. So I can have the roof materials, for example, the asbestos, the concrete, and the metal. And also the degradation status or the age of the roof also can be detected. For example, okay, this one is new asbestos, this one old asbestos, this one new concrete, okay, this one is new metal, and so on. Okay, right. So this is the map, right? Okay. Next, from the result also, okay, we can use for developing the model or the 3D model of building. Okay, like this. Okay, and also each of the building will have their attributes. Okay, if you can see here, this is the example of attribute that we can extract. Okay, for example here, we have the types of materials, for example, the concrete, and then we can know the degradation status. This is the old concrete, the old roof, and then we can have the height of the building, okay, the perimeter of the roof, and here is the area of the roof. Okay, the area is one of the parameter in order to determine whether this roof is suitable to be selected for the rooftop rainwater harvesting system or not. Okay, and from this area also we can estimate the volume, the estimated volume for rooftop rainwater harvesting. Okay, so instead of that, here we also can have the quality of the rainwater for each of the roof, yeah, for each of the roof. Okay, so here we have the pH value, the magnesium, the TDS, and actually it can be many more. Okay, so for this study I only show the three parameters of the rainwater quality. Okay, so for information, this output is very significant for the local authority, especially for environmental quality assessment and evaluation. And this output actually I provide for National Hydraulic Research Institute of Malaysia, NAHRIM, in order for them to determine the suitability of roof that to be used for rooftop rainwater harvesting systems. Okay, in terms of the quality and quantity. And interestingly, this study had won gold medal in one of the international innovation competition that I involved a few years back. Okay. All right, this is the example. For example, this one, it represents the old metal. Okay, roof usually will be misclassified with the land use, land cover such as road, and for example this one, the old metal misclassified, okay, with old asbestos, okay, and new asbestos. That's why we need to reduce the issue or the problems of misclassification, but by optimizing the method of remote sensing, okay, the image processing method. Okay, this one is new metal, this one is new concrete, and this one the example of old asbestos. Okay, old asbestos is very dangerous, okay, because it can cause a Mesopotamia cancer, okay, asbestos actually. Okay, that's why it is important to identify this type of roof materials, okay, so that it can be replaced with other roof materials. Okay. All right, so it comes to the conclusion. Okay, as a conclusion, the final result that we can obtain from this study is we can classify, categorize the roof materials. we can identify or detect the degradation level or the degradation status of the roof materials, and also we can produce informative 3D model of building. And from that, the benefits is we can evaluate the roof, whether the roof is suitable for rooftop rainwater harvesting system or not. Okay, and as a recommendation for the image processing, okay, of course, it is valuable if we can apply deep learning or programming based technique, programming based such as Python. Okay, and then this study, they have the potential commercialization. For example, for JPS, Jabatan Pengairan and Saliran Malaysia, Kementerian Sumber Asli dan Alam Sekitar, and also National Hydraulic Research Institute of Malaysia, NAHRIM. Okay, alright, so this is among the publications that related to this study. So we managed to publish several publication. Okay, and you can extract or you can have the, if you're interested, you can have the paper, okay, using this DOI link. Okay. Alright, this is just for sharing. Okay, this is the pictures taken during the International Innovation Competition in 2018. So we managed to grab the gold medal in this competition for this study, for the 3D building, 3D model building. Okay. Alright, so I think that's all. Thank you. If you have further queries or you want to know further information about the postgrad study, you can contact Center of Postgrad Study, or you can contact our faculty, and you also can contact me direct, okay, via the email and phone number. Alright, so I think that's all that I can share today. Maybe we can see in the next time, and please do not hesitate to have a discussion if you are interested with our research or our area. All right, then thank you very much and Assalamualaikum.
Okay, terima kasih kepada Dr. Masayu di atas perkongsian yang menarik. Okay, sekarang ni saya buka QA session untuk ditanyakan kepada our speakers. So kalau ada persoalan boleh kemukakan ataupun boleh type di bahagian chat room. So ada soalan?
Boleh tak nak tanya Encik Hafiz sikit?
Boleh.
Sorry Encik Hafiz, because
Hello. Tak apa, okey, ada.
sebab tu macam ada related sikit kan, especially on the image classification and object identification tu kan.
Okey.
Okay, so kan macam yang Cik Hafiz detect the object, for example yang ikan, and then you boleh detect whether dia fresh ke ataupun dia damage tu kan. So what kind of macam parameter ataupun apa yang you guna untuk you detect the condition of ikan tu? Maksud saya adakah you guna wavelength, okay, wavelength ataupun the reflectance from the objects, atau you just from the image, okay, you identify kalau dia nampak macam red colour sikit, okay, this is the damaged fish, macam tu. Atau you ada any, macam saya kata, any parameter ataupun any variable yang you guna. Faham tak?
Okey. Faham. Ni apa, kita tengok parameter tu daripada Jabatan Perikanan. So kita konsult dengan Jabatan Perikanan. So dia ada publish satu kaedah cara untuk orang ramai untuk kenal pasti kan apa beza antara ikan fresh atau tak. Dia depend pada spesies ikan. Dia tak boleh guna pada semua jenis ikan. So So dia ada kalau ikan siakat, ikan kembung. So kita tengok parameter tu. Lepas tu kita follow dia punya parameter. Salah satu dia adalah texture. So texture kita tengok dia punya feature dia naik turun ke apa semua. Okay, kalau reflectant tu ada guna juga dekat mata dengan dia punya body dia tu nampak macam highly reflective ataupun dia mula dull, dull colour. Itu texture.
Okay,
Color ni.
So macam reflectance tu atau texture tu, is it dia bagi dalam bentuk value ke, pixel value, ataupun dia ada dia punya brightness ke?
Dia ada macam okay.
Itulah maksudnya dia bagi in terms of.
So yang ni dia macam fuzzy. So sebab saya kerja sama dengan Dr. Tajul, dia macam buat pasal fuzzy logic macam tu kan, fuzzy punya set. Maksudnya kita tak cuba buat dia secara macam Crips tu. Macam Crips tu macam kita dah siap dah kata kalau lebih parameter ni dia macam fresh. Kalau kurang dia jadi tak fresh. Tak. Kita buat macam kita kena ada satu human expert duduk kat sebelah. Lepas tu kita akan sort tu secara manual dulu. Kita sort benda tu secara manual. Lepas tu bila kita train neural network, neural network tu dia akan try untuk imitate human tu untuk detect. Dia macam contoh macam yang highway tadi. Yang case highway tadi, untuk komputer tu detect benda tu busy ataupun tak, dia tak bilang tau satu-satu kenderaan tu, dia tak bilang satu. dia tak bilang kata 10 tu busy, maknanya dia tak ada threshold macam dia kata lebih daripada 10 tu kata busy, kurang tak. Dia buat macam manusia juga. So dia macam dia macam agak tapi bukan agak, dia ada macam
from image interpretation lah.
Image interpretation. So
Okay. Alright, thank you Cik Hafiz.
Alright.
Ada lagi soalan daripada mana-mana listener kita? Kita buka lagi QA session kita. Ada lagi soalan?
Okay, boleh tanya apa-apa pun.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Boleh saya tanya soalan?
Salam, boleh.
Okay, nama saya Zuraihan binti Mohammad dari FSPU juga. So my question is to Dr. Masayu binti Haji Norman. Okay, so based on my knowledge, I know that the remote sensing image can be classified into high resolution, medium resolution, and also low resolution. Okay, so based on your expertise, okay, so the OBIA technique, okay, which type of image is more suitable to be applied for this type of classification and why? That is my question. Thank you.
Okay, thank you Ms. Zuraihan. Okay, actually in what application that you mentioned?
Any application, for example, for forestry or for utility mapping.
Okay, actually in order to decide which image that are suitable for certain application, it depends on the requirement that we need. If we just need a general result, okay, or general application, so that we can use only the low resolution image. But if you require to have an information or to obtain the result for very detailed information, so definitely you have to choose the high resolution image and high spectral resolution image. Okay, just like my presentation just now, if I want to extract the detail of the roof, okay, for example, the status of the roof, the degradation status of the roof, whether it is old or new, so I have to use the high resolution image with high spectral resolution image. Okay, can you get the answer, Ms. Zuraihan?
So based on what Dr. explanation, is it that this technique, the OBIA technique, the OBIA classification technique, is only suitable to be used for a high resolution image, and it is not suitable for low resolution one?
Yes, yes, it is suitable for, actually we can use for low resolution, but it is not so significant, because for low resolution actually we can use the pixel base. Okay, use the pixel base. So for the object base, we are using the high resolution because it will give high accuracy. That's why it's developed the OBIA technique. Okay, because to reduce or to avoid the misclassification problems in classification remote sensing.
Okay, I understand. Thank you, Doctor.
Okay, you're welcome.
Alright, so is there any question? Floor, any question? If you want, anybody want to ask any more question? No?
Assalamualaikum.
Salam.
Cik Hafiz Saya Samsuri. Muhammad Saleh. Boleh tanya soalan sikit
Boleh Cik Syamsuri.
daripada
Silakan.
SPU juga. Saya tertarik dengan Cik Hafiz punya apa tu? Yang rumput panjang.
Okay,
Okay.
monitoring.
Itu yang dia pakai kamera kan?
Ya.
Kamera. Yang satu lagi yang kamera tu dia permanent dekat situ lah, dekat building ataupun kita
Permanent. Camera, actually itu camera from
360 degree dia punya tu.
small office, home office camera.
Oh, satu lagi dia boleh integrate lah dengan apa ni, macam intelligent building system BACnet, apa tu building automation control networks tu. Macam
building automation. Okay,
ya,
kamera
untuk data apa semua lah, untuk kita nak monitor apa semua kan.
Ya, possible. Dia possible. Ada possibility untuk kita sometimes kita boleh guna CCTV tu macam untuk monitor parking. Okay, can use it.
Satu lagi macam intelligent building ni dia guna sensor kan. Kalau cuaca kat luar tu panas, kemudian automatic dia sensor tu dia akan hantar kepada macam sistem ni, dan dia akan control lah air conditioning system kan, panas sejuk kan. Dia punya apa ni, cooling load ni kan. Maksud dia boleh interface lah
dia boleh interface juga.
Maksud dia network protocol dia boleh interface lah.
Ya, boleh. Asal kita ada training data dengan tu lah, apa kita kena collect dulu data untuk range value yang kita nak lah.
Oh, okay. Bagus. Tertarik juga lah dengan sistem tu.
Yalah, dia boleh adapt juga.
Satu lagi traffic tu memang perlu lah kan, sebab orang duk tengok selalu monitor kan, pening kan. Kita nak identify tu sesak, mungkin boleh tambah sikit kot, bila sesak kita boleh divert ke mana jalan tu kan.
Itulah dia sebenarnya benda tu step by step. First we need to train to detect, and then lepas tu kita kena go forward from there lah. Lepas tu dia kena buat pula kan sistem lain pula untuk divert.
Mungkin nanti future
fundamental dia
mungkin boleh tambah untuk banjir pula kan. Kawasan banjir, naik sungai tinggi mana pula kan. So dia warning system pula. Bagus lah. Okay. Masih.
Kita masih ada soalan daripada from the floor. More question? Right, Dr. Masayu, I hope that you can contact that person personally. Alright, so that's it for today. So kita thank you kepada our speakers for their interesting sharing today. So thank you for all listener. Right, so boleh diminta boleh untuk mengisi attendance, kedatangan. So untuk itu saya menamatkan sesi webinar kita pada hari ini. So ucapkan sekali lagi terima kasih kepada Encik Muhammad Hafiz Ismail dan juga Dr. Masayu binti Haji Noman. So dengan itu berakhirnya sesi kita pada ini. Assalamualaikum dan terima kasih.
Okay, Waalaikumsalam. Thank you.
Water. Position. Dalam position tu boleh isi apa? Presenter. Ada apa? Ada.